Good afternoon, everybody. It's a great pleasure to be here and talk to you about my experience in about a decade now doing public engagement and outreach in schools and elsewhere. As a professional scientist, an astrophysicist here in the astrophysics group of Imperial College London, I think it's part of the duties of a scientist to go out and engage the public, especially the young adults and primary school children, with the science that we're doing, especially kind of fundamental science to do with the big questions about the universe that I do. What is the universe made of? Where did it come from? And how will it end in the future? The starting point for me today is the beauty of the night sky. Of course, this is something that we are not very familiar anymore with because of our light pollution in our cities, but that's something that fascinates children and children of all ages, really. And so this is a fantastic hook for us doing fundamental science to do with the universe in terms of talking about science that's exciting and science that really tackles the biggest questions of humanity. And so one of the things that I've been trying to do in my work has been to always tap into this incredible enthusiasm, this curiosity, this fascination, these great questions that children always have about the universe. And so I've been trying to look for ways of nurturing that curiosity, talking about science, certainly, but not just on an intellectual level, and a level that people could relate with, at a level that's engaging, that's enthusiasm generating, and that's exciting. So Earth, why is there day and light? Day and night, I'm sorry, why is there day and light?
From the way the light is hitting the Earth.
That's right, and why does it change? Because
I'm rotating.
Please do. And why are there seasons? Why is there winter and summer?
Because of the tilt.
Because of the tilt, but also because... Yes, very good. This works best after a beer or two.
I was going to say.
And also because
You're going around.
You're going around.
Can
you go around and tilt and rotate? Thank you. Moon, are you ready? Great, you're a great moon. Can you come across? And so now, of course, this takes about 20 minutes in a class, as you can imagine, and we've done the 20 seconds sort of speed up version here. And so now, can you do it all together on the count of three? On the count of three. 1, 2, 3, go. Great, awesome, round of applause, thank you. Thank you so much, fantastic stuff, thank you. So what I want to do next, I want to build the solar system here in front of you. So I'm gonna stick the sun here, one end of our solar system. Here, so that's going to be the sun. What we're going to do, we're going to do it like this. We're going to build the solar system in these directions so that the scarf here conveniently marks the end of the solar system to scale and to size as well. Roughly to scale, Mercury is 50 centimeters away. Venus 30 centimeters away, Earth next door 40 centimeters away roughly, and Mars 60 centimeters away. So they're all really bunched up together in a way that we usually don't think about them this way. Jupiter is about 2 meters away, so it would be a little bit further in, actually, here. What's my map? Yeah, let me be here. Okay, the biggest, of course, is Jupiter. Then we have Saturn, a little bit closer in, like that. And then we have Uranus, at 7 meters here. That's Uranus, actually. And Neptune, on this scale, would be all the way here. Yeah, I know, that's cheating. Here, right? You get the sense? And if you wanted to go all the way to Pluto, it would be at the back of the room, even. So, this gives you a sense of scale, how, our inner solar system is really, really tiny compared to everything else. And if you want to spice it all up a little bit, you want to add, perhaps, peppercorns for the meteor belt here. Between Mars and Jupiter, sprinkle some of them too. Okay? This is a picture of the universe in very large scales, and it has a dark side. A side that's unexplained, mysterious, and very much at the forefront of cutting-edge modern research. How can we make that kind of questions and these kind of big thoughts accessible and understandable? Let's start by looking at the universe, again, in a way that we can relate, perhaps, with our senses. And so the idea here is to look at the sky, very much like we would do in a very clear night, and look at the moon. This is the moon, the full moon in the sky. We have all a sense of how big the moon appears on the sky, more or less. But what I want you to do, I want you to focus on this tiny little patch of the sky. You can see how small it is compared to the size of the full moon. This is, in fact, a patch of the sky so small that it would fit into the eye of a needle held at arm's length. So it's a tiny bit of the sky out there. But if you look at it with the most powerful telescope we have, the Hubble Space Telescope, this is what it looks like. Each one of those dots is a galaxy containing about 100 billion stars, just like the sun, and there are about 5,500 galaxies in that eye of a needle on the sky. And I lie you not, because if I zoom in, you can really recognize those dots to be entire galaxies, spiral galaxies and elliptical galaxies and so on. And all of this stuff out there fits in the eye of a needle. So you do the maths and imagine how much there is in the rest of the sky. And the answer is about 50 billion galaxies in the visible universe alone. And yet, one of the most astonishing discoveries of modern cosmology is that this is but the tip of the iceberg of what it's out there. The breaking news is the universe is 96% of the universe is missing. So all the stuff that you saw in that picture was really just nothing at all. 4% of the total was on that picture. And so here is the cosmic recipe, if you like, what I call the cosmic recipe, the cosmic pie. We have a very tiny little part of the cosmic recipe here. This much is made of matter we know about. You can see here in this cosmic pie, this sliver here, the yellow sliver is the stuff you saw in the previous picture. Tiny fraction of the total. The 4% that we know about is this much of the universe, and it's made of the kind of matter and energy that we understand and we know based on our models of particle physics, the most advanced physics that we know. And so this amount is known. 25% of the universe made of dark matter, more about which in a second, here, which is a different type of matter, possibly a new type of particle, and an incredible 70% of the universe, which we call dark energy, which in my book is called the dark push, which is an unknown form of energy that's making the universe expand faster and faster with time, and it's ripping the universe apart, essentially. So this 96% of the universe, the dark matter and the dark energy in the universe, is what we are trying to understand in places like this, and that's very much the focus of my research. Thank you very much for your participation, for you being here. Thank you.